This is 11.2 for statistic class. We're talking about contingency tables, tests of independence, and tests of homogeneity using chi-square distribution. So the first question is asking us that a company table summarizes the success and failures when subject use different methods when trying to stop smoking. So this is, we try to figure out that some people want to stop smoking and they have all these, what we call as methods. There are 3 different methods here, and we want to figure out if they have success smoking or not. Now, the number that you see up in without the parentheses is what we call as an observed frequency. You have to find the total by yourself by adding your observed frequency out. You have to find the column. This is called the column total, and you also need to find the row total, and after that you find the grand total by adding your totals. So the parenthesis number is what is a number for expected frequency, and I will teach you how to find that in question A. Okay. To determine if smoking or not smoking was made 5 months after treatments began. So the claim in this case is to test for success is independent of the method used, assuming 0.05 significant level. So this is a test of independent, since the question is calling us to test independent. What is that telling us? That you want to figure out if you quit smoking or not, is that the independent or depending on the methods you use here? Okay, so so first thing first is we want to find the expected frequency. So how to find the expected frequency? Add up all your columns, add up all your rows, your total, and then add up the whole totals, the grand totals. It means you can add 250, 320, 122, or you can add 549 and 143, you get 692. So those are the first thing you have to do. And then next, in order for us to find the expected frequency of the one that's smoking who use nicotine gum, you have to take 250 times 549 divided by 692. So if you take 250 times 549 divided by 692, you get 198.338. So that's why you get 198.34. And then if you want to find the one for a non-smoking one, you take 250 with nicotine gum, 250 times 143 divided by 692. So if you use your calculator to figure it out, you get 51.66. And for the nicotine patch who is smoking here is 320 times 549 divided by 692. So 320 divided by 5 times 549 divided by 692, you get 253.87. And you repeat the same for non-smoking who use nicotine patch. Is 320 times 143 divided by 692. That is given us by 66.13. And then now doing the nicotine inhaler who is smoking is 122 times 549 divided by 692. That you get 96.78, 79 in this case. For the non-smoking who use nicotine inhaler is 122 times 143 divided by 692, and you get 25.21. So as you know that your expected frequency has to be in decimals. Rule of thumb, 2 to 3 decimal places you have to round. So this is how we find expected frequency in A. Okay. B, they ask you to find the p-value, and what does the p-value tell us about the claim? So in order for us to find the p-value, you have to do your matrix first. So X equals to matrix C. Now how do you read this? Is you read it down. So you read 191, 59, do not include your total. I do not want your total here because that is not your observed frequency. So you just need to go without your total. And then next you go to the next column, 263, 57, 95, 27. Again, you do not need to include any total. So this total, row total, grand total, column total, do not include in your matrix. And then put a comma and column equals to 3. This is telling us that we got 3 columns in this case. Okay, your data have 3 columns. So and then when you put it in your R, and you hit X, you find out that this matrix that you build is exactly the same table that you have. If your matrix that you have here has a different numbers or different way than this table, then you will get it wrong. Okay, and then you do this chi-square dot test, X correct equals to false, and this is what you will get. You will get a Pearson's chi-square test. This is your test statistic, 3.0618 chi-square, and this is your p-value. The degree of freedom in this case is 2. So the p-value in this case is 0.2163. In this case, which is greater than alpha, 0.05, so we fail to reject H0. So if you fail to reject H0, then we will say that this 2 is not independent. The row and the column is not independent. So the success of quitting smoking or not is totally independent on the 3 different methods used. So what is this conclusions tell us? These conclusions tell us that these two have nothing to do with each other. Independent means that so that means that if you quit smoking or not quit smoking, and if you want to use any of these way to try your best to quit smoking or not, these are two totally not related, not independent at all. Okay, by finding this using this sample or example. Next, find the number of degree of freedoms. There are 2 ways for us to find the degree of freedoms. One is using R, which is degree of freedom here is 2. The other way is using the formula. You take the number of row minus 1 times number of column minus 1. So we got 2 rows here, so 2 minus 1 is 1. And then we got 3 columns here, so 3 minus 1 is 2. So 1 times 2 is 2, which is again here. And then you need to find a critical value. So to find a critical value is you do q chi-square 1 minus alpha. The alpha in this case is 0.05, and then and the degree of freedom in this case is 2. So in this case is q chi-square 1 minus alpha, 2, which you will get 5.99. And then the question is asking, is this a right, left, or two-tail? Explain. This is a right tail test. The reason why that every time when you do a chi-square distribution, it's always skewed to the right, and this is the reason why that in chapter 11, I'm sorry, when you use a chi-square distribution, you always have a right tail test in this case.